Chapter 7, Atmospheric Pressure and Wind, Actual Global Circulation, Important Features. So now what we're going to do is we're going to compare the three-cell graphical model that I created with actual surface pressure patterns and wind patterns based on a number of years of data averaged. So this is the graphical model that I introduced, a three-cell model, and the dominant pressure patterns here are at the equator, the intertropical convergence zone, a band of low pressure systems. At 30 degrees north and 30 degrees south, the subtropical high pressure system, and at roughly 60 degrees north and south, the polar lows or mid-latitude cyclones is what they actually are. Okay, in terms of global wind systems, we have the northeast trades and the southeast trades. Northeast in the northern hemisphere, southeast in the southern hemisphere. The trade winds blow from a higher latitude to a lower latitude in an east to west direction. In between the subtropical highs and the polar lows, we have the westerlies, and they blow from lower latitude west to east in the higher latitudes. And then the final band of winds are the polar easterlies that blow from west to east, and they blow towards the equator. So let's see if we can identify on 50 years of average wind data and pressure data, the intertropical convergence zone, a band of low pressures that exist along the equator or close to the equator. So let's begin by looking at data for January, and that orange line with the lows embedded in it, that's our intertropical convergence zone. Here is the average data for July, and once again, the orange line represents the intertropical convergence zone. Notice it moves quite a bit away from the equator in July because of the warming of the Eurasian continent, and the enhancement of the monsoon wind systems. So it doesn't do that in January in the southern hemisphere. Let's see if we can identify the northeast and southeast trade winds. So the northeast in the northern hemisphere, the southeast in the southern hemisphere. And let's begin with 50 years of January data. So those yellow arrows, you can see the winds that are actually on the map. I put those yellow arrows in, and they're indicating an east to west towards the equator wind direction, which is what you would find with the trade winds. So you can see where the trade winds are obvious, mainly over the oceans, not necessarily over land masses. And there's our pattern, our trade winds. And here's the same thing now for July, 50 years of data. Notice that the trade winds break up over the Asian continent. But once again, they're most obvious over the oceans. Let's see if we can find our subtropical high pressure systems for the 50 years of data. So here's January, so the black boxes indicate where the subtropical highs are. So they almost form a continuous band in January in the northern hemisphere. And there they are in the southern hemisphere. They're broken up by lows over South Africa and South America, and the low that develops because of the extreme heating in January over Australia. Here's the location of the subtropical highs in July. More of a continuous band in the southern hemisphere. Once again broken up in the northern hemisphere because of the heating of land during the summer months. so not as big of a continuous band across the northern latitudes. Let's see if we can identify the westerly winds. Now these are going to be a little bit more difficult because they are influenced to great degree by the continental masses that occur in the northern hemisphere. So here's January, so we can only see westerlies in 2 locations, in the Pacific and the Atlantic, but they do seem to form a continuous band in the southern hemisphere, approaching low pressure systems that exist along the margin of Antarctica. The westerlies become a little bit more obvious in July in the northern hemisphere, so a little bit more extensive. Still, a pretty continuous band in the southern hemisphere, moving out of the subtropical highs and into the polar lows. So the final thing we want to identify on our actual data is the location of the polar lows. These polar lows, once again, are going to be more continuous in the southern hemisphere because there isn't landmass breaking them up. Less continuous in the northern hemisphere. So here we see January, 50 years of data, average pressure patterns and wind patterns. In the northern hemisphere, we can see that the polar lows are obvious over the Aleutian Islands, Iceland, and once again over the Aleutian Islands on the other side of the map. Continuous band in the southern hemisphere, and they are quite close to the margin of Antarctica. Here we have July data, so the lows now are over more over land masses, over Alaska, northeastern Canada, still Iceland, and eastern Siberia, and once again pretty much a continuous band in the southern hemisphere. The polar lows are quite obvious, and that's it. It's very hard to see the polar or the polar easterly winds on this map, so we won't try to locate them.